So here's number 10 from Summer Review 7, and it was f of x equals 3x squared plus x minus 4 all over 2x squared minus 5x. So we kind of made it equal to y. And then if we want to find our zeros, we want to find out whatever makes the top 0 without making the bottom 0. So what I had to do is I had to factor this, so I kind of factored it over here. And there's different techniques you can use. I just tried 3 and 1. I knew my only possible factors for 4 would be 1 and 4 or 2 and 2, so it wasn't too many trials and errors. So I could do it like that, or there's another method that you learn in Algebra 2 that you can expand that out. So y will equal 0 when x equals 1, or when x equals negative 4/3 or negative 1 1/3. So there's a couple points that I know I have on there. Now, x will equal 0. Well, if we look at this and we factor this, the denominator, we have x times 2x minus 5, so x can't be 0 because I have 0 in the denominator. So that's going to be an asymptote, a vertical asymptote. We'll see that in just a second. So I can put these points on here, 1, 0. So I have a point here, 1, 0, and I have a point here, negative 4/3 or negative 1 1/3. So those are a couple points on there. All right. And it doesn't look like it's odd or even because we've got these terms in here that are going to foul things up. So we can't get any relief that way. So let's check a look at the horizontal asymptotes. Now I look at the degree of my highest terms here. And those are both the same. So I do have a horizontal asymptote, and that it equals the ratio of these coefficients. So my horizontal asymptote is y equals 3/2, 3 over 2, or 1.5, 1.5. Now I have vertical asymptotes when x equals 0. Nothing divides out, so x equals 0. And when x equals, and then if I solve this, if I set this equal to 0, I add 5 divided by 2 is 5 over 2, or 2.5. Okay, so we can put those in and get an idea of what's going on. So my horizontal asymptote is at 1.5, so it'll be right here, so I'll put a point here right between. Maybe put a guide point over there. Try to make sure that's level. So there's my horizontal asymptote, and I have a vertical asymptote at x equals 0. So those are kind of hard because that's the axis. So I'll try to draw it a little bit to the left of the axis so you can see that. But it is the axis. And then x equals 2.5, so it's going to be 2.5. So we got some fractions again. We put a couple guide points there, so that should be even, 2.5. And there's my other vertical asymptote. So now we just have to check the behavior. Now it looks like it's going to come down like this because we got a point here, so we can kind of go along with that. I take a chance. It looks like it's save us a little bit of time because we do have a point here, so we're probably going to go something like this. I mean, it could cross the asymptote and do some crazy stuff, but it's a pretty standard polynomial, so I'm going to say probably pretty much like this. I could go back to my 8x8 grid because this will fit. Actually, I could have done some of the other ones on that. I was using the 16x16. Okay, so there's that branch. So that saves me a little bit of time. Now what's happening over here? Now this could go like this. It could go like this. It could go like this. It could go like that. So I got a lot of possibilities. So I'm going to have to check the behavior right around this asymptote. So I'm going to have to check as x approaches 0, and it's going to be from the right. I know I have a good idea what's happening as x approaches 0 from the left, but as x approaches 0 from the right, we put a little plus there. So x is approaching 0 from the positive direction. So I'll write my expression up here. And I could just substitute 0 in, and this won't be a problem. I can put 0 in here. That's not a problem. I get 4. And I could put a 0 in here. I get -1. That's not a problem. I can put a 0 in here. I get -5. But I can't put a 0 in there because that's where the problem is. So I can rewrite it like that. So that's what's happening right around 0, and a negative over a negative is a positive, so I just end up with 4/5 over x. All right. So let's see what's happening as I approach x, as I approach 0 from the positive direction. So that's going to be and that would be real close to 0 would be 0.0001. We could have a bunch of zeros, okay. So that's as I approach 0 from the positive direction, and you can see that this is positive, and this is going to be approach infinity, so it's going to, as this number gets really small, the fraction gets really large, so I got 4/5 of infinity, so I just have positive infinity. So it looks like I'm going to be like this. Okay, right around this asymptote. Now what's going to happen down here? Okay, well, it can either go back up like this, or it can go down like this. So I can bring it down a little bit, but let me kind of wait and see what's happening over here. So let's see what's going on as x approaches 2.5 from the negative direction. So as x approaches 2.5 from the negative direction. Okay, 2.5. Oh man. So we're going to have to put 2.5 in all these and see how that works. So y would equal, and I could put 2.5 in here, and 3 times 2.5. That's 3 times 2.5 is 7.5 plus 4 is 11.5, so it's 11.5. That's okay. And then if I put 2.5 in here, minus 1 is 1.5. And then on the bottom, I can put 2.5 in here, and that's okay. And I just get 2.5. And over here, this is where I'm going to have trouble because I can't put 2.5 in here. So I got -5. Okay? All right, so we're using a small approach. Now, we just usually do these things just for the SIGNs because we're going to be either positive infinity or negative infinity because it's an asymptote. So I don't need to worry about calculating these out. I could just say that this is going to be positive, that's going to be positive. So this is really what I'm worried about. So I'll just say y equals, some number over 1 over 2x minus 5. Now as x approaches 2.5 from the positive direction, I'm sorry, from the negative direction, excuse me. Then that's going to be maybe like, 2 times x, and that's going to be something like this. All right, so I'm approaching it from the negative direction, so that'd be 2.4 and then 9999999. Okay? All right, so I think you can see that. All right. I hope this makes sense so far. This is kind of a hassle because of the fractions. So this number is going to be definitely, if I look at this, this is going to be 2 times 2.5 is 5, so this is going to be a negative. So I'm going to end up with because 2.5 would be 5, so this would be less than 5. All right, so I'm going to end up with a negative and a very, very small number. And we'll just say negative. That's going to be double, but after we subtract it, it might be 0. And it might be 2 rather than 1 because I'm doubling it. But it'd be very small. Either way, I got a negative because this is going to be smaller than 5. This is going to be, so the 5 would be have the larger sign. So it's going to be a negative infinity. There you go. So it's kind of complicated to do it like that, but it works out. So it's a negative infinity. So it looks like I'm coming down here. So it looks like I'm going to be curving right down through this. And we're going to go down to negative infinity. So there we go. Now we have to do the same thing and check it over here because we don't have any checkpoints. So is it going to go like this or is it going to go like that? So we have to see what happens by my asymptote right over here. So that's going to be as x approaches, two and a half or 2.5 from the positive direction. So we've already got this all worked out. So it's going to be like this: y equals 1 over 2x minus 5. So that's going to be y equals 1 over, I think we can already intuitively see what's going on, 2 times, and then it's going to be like 2.50001 minus 5. And again, this is going to be, when we double that, it's going to be bigger than 5, so it's going to be positive. So y is going to end up being 1 over a very, very small number. When we do this, 0.000, and it might be 2 because we're doubling this here, I think. Could be 1, I'm not going to work it out right now, but 1 or 2 doesn't matter because it's going to be positive infinity. All right? And we're just mostly looking for the SIGN, so positive infinity, so that means it's going to be like this. And you could put some more checkpoints in here if you really want to check the bend, but something like that. All right? So that's how we worked it out. Let's check it with a calculator real fast. I think I've got time on this video here. I already put in the calculator to save time. So there's my function, and there's my asymptote, my horizontal asymptote, which I can graph. And then I got my window set. So let's graph it. And that looks good. That looks good, and looks very good. And there's the asymptote coming along right there. So it looks like we got it. Okay. Took about 13 minutes, so they're kind of challenging. And you could, in pre-calculus you tried use checkpoints, but here we can just use this other analytical method. Okay, so I hope that makes sense. So there's your branch, there's this, and there's that. So it looks like we're okay.